Did you know in a single quiet breath, your lungs can capture enough oxygen to power a small light bulb for nearly an hour? This is a startling fact. It shows the hidden power in something we do all the time. Breathing is an action we rarely think about. It is the steady, silent rhythm of our lives. We take about 20,000 breaths each day. Yet behind this simple act is a complex and beautiful process. Your body performs a small miracle with every inhalation. It transforms the air around us into the very energy that fuels our thought, fuels our movement, and fuels our heartbeat. This essay will explore that incredible journey. It will follow the path of oxygen from the air into your cells. This journey matters deeply. Understanding it is not just for scientists or doctors. It is for everyone who wants to appreciate their own body. It is for anyone who wants to live a healthier life. The process of breathing is directly linked to our energy levels, our mental clarity, and our overall well-being. When we trace the path of oxygen, we uncover the secrets to our own vitality. We learn how a simple, deep breath can be a powerful tool for health. The story of oxygen is the story of life itself. It begins with one small intake of air. It ends with the spark of energy in trillions of cells. Let's begin this journey together and see the unseen. The path of oxygen is like a sophisticated delivery system. Imagine a vast, intricate network of roads and messengers all working in perfect harmony. The air you breathe is the precious cargo. The core of our respiratory system is a simple but vital process. It is called gas exchange. This is the moment when the outside world truly connects with your inner world. It is a microscopic trade that happens millions of times with every breath. In this exchange, your body takes in oxygen. Oxygen, it desperately needs it. At the same time, it gets rid of a waste product. That waste product is carbon dioxide. Carbon dioxide, expelled from the body. This critical trade happens deep inside your lungs, in countless tiny, delicate air sacs. Scientists call them alveoli. Alveoli, the final destination for the air you breathe. Your lungs are not just two empty balloons. They are filled with microscopic structures. Each lung contains hundreds of millions of alveoli. Unfolded and laid flat, they'd cover a tennis court. That massive surface area is the key to efficient gas exchange. It gives enormous space for oxygen to enter. The walls of alveoli are incredibly thin, only 1 cell thick. That thinness is crucial. It lets gases pass with remarkable ease. Gases move from the air into your bloodstream. Wrapped around each alveolus is a web of tiny blood vessels. These are capillaries. Capillary walls are also 1 cell thick. That creates a very short distance for gases to travel. Here, blood returned from your body arrives. It is low in oxygen. It is high in carbon dioxide. As blood flows past the air-filled alveoli, the exchange begins. Oxygen molecules move from high concentration in the lungs to low concentration in the blood. Like sugar dissolving in water, the oxygen moves to where there's less of it. Simultaneously, carbon dioxide does the opposite. This swap takes less than a second. Now, oxygen-rich blood flows away from the lungs, ready to be pumped to the body. Carbon dioxide sits in the lungs, waiting to be exhaled. With one gentle breath out, you release it into the atmosphere. This elegant, silent exchange is the foundation of your survival. It is the first step in turning a simple breath into life-sustaining energy. Your lungs are masterfully designed for one primary purpose: moving air. They are a brilliant example of natural engineering built to maximize airflow and gas exchange. The journey of air begins when you breathe in through your nose, mouth. Your nose is the preferred entrance. It warms the air, it moistens the air, it filters the air. From there, the air travels down your trachea, the windpipe. The trachea is a sturdy, flexible tube reinforced with rings of cartilage to keep it from collapsing. It is the main highway for air entering your chest. Deeper in your chest, this highway splits into 2 smaller roads. These 2 main branches are called the bronchi. One leads into your right lung, the other leads into your left lung. But the branching does not stop there. Inside each lung, the bronchi divide again and again like the branches of a tree. They become progressively smaller and smaller, creating an intricate network of airways. These smaller tubes are called bronchioles. This branching structure ensures that the air you inhale is distributed evenly and deeply throughout the entire lung tissue. At the very end of the tiniest bronchioles, you find the clusters of alveoli. Those tiny grape-like sacs where the real work of gas exchange happens. This entire structure is often called the respiratory tree. Your lungs themselves are soft, spongy organs. They are nestled within your chest cavity, protected by your rib cage. The heart sits snugly between them, slightly to the left. Underneath the lungs lies a large, dome-shaped muscle. This is the diaphragm, the unsung hero of breathing. When you take a breath in, your diaphragm contracts and pulls downward. This simple movement increases the volume of your chest cavity. This expansion creates a negative pressure, like a vacuum, which pulls air into your lungs. It is an active process, requiring muscle effort. The lungs themselves are passive. They simply fill the space that is created for them. When you breathe out, the opposite happens. Your diaphragm relaxes, moving back up to its resting position. This decreases the volume of your chest cavity. The natural elasticity of your lungs causes them to gently recoil, pushing the air out. Normal exhalation is a passive process. It requires no effort at all. This rhythmic movement of the diaphragm and chest muscles is what drives the constant flow of air. It is like a simple bellows, drawing air in and pushing it out. This elegant mechanical system ensures that your lungs are continuously ventilated, ready for the next great exchange of gases. Once oxygen passes from the alveoli into the bloodstream, it needs a ride. It cannot simply float around in the blood plasma on its own. This is where red blood cells come in. These remarkable cells are the dedicated oxygen couriers of your body. They are incredibly numerous. A single drop of your blood contains millions of them. They are small, flexible, unique biconcave shape, a flattened disc, indented in the center. This shape increases surface area, allowing them to absorb and release oxygen more efficiently. The primary job is to pick up oxygen in the lungs and deliver it precisely where it is needed. The secret is a protein packed inside, hemoglobin. This protein is called hemoglobin. Each red blood cell contains about 270 million hemoglobin molecules. Hemoglobin gives blood its red color, and it binds oxygen. Think of hemoglobin as a molecular magnet for oxygen. In oxygen-rich lungs, hemoglobin grabs oxygen molecules. One hemoglobin can carry up to 4 oxygen molecules. This binding is fast and efficient, happening as the red blood cell zips through the lung capillaries. After loading with oxygen in the lungs, the bright red blood returns to the heart. The heart pumps oxygenated blood out through arteries and capillaries. As red blood cells travel to your muscles, your brain, your organs, they encounter an environment with lower oxygen levels. That signals hemoglobin to release its precious cargo. Oxygen detaches and crosses from blood into the body's cells. Delivery is as crucial as pickup. It ensures that every cell gets the oxygen it needs to perform its functions. The red blood cell's job continues. After dropping off oxygen, it helps remove waste. Some carbon dioxide produced by the cells will attach to the hemoglobin for the trip back to the lungs. However, most carbon dioxide is transported in the blood in other ways, primarily dissolved in the plasma. These RBCs, now CO2-rich and O2-poor, return to the heart via veins. The heart sends deoxygenated blood back to the lungs to release CO2 and pick up oxygen. This circular journey repeats with every heartbeat. So, why does your body go through all this trouble to deliver oxygen to every cell? The answer lies in a process called metabolism. Metabolism is the sum of all the chemical reactions that keep you alive. A central part of metabolism is creating energy. Your cells get a basic fuel source from the food you eat, primarily in the form of a sugar called glucose. However, glucose on its own is not enough. To unlock the vast amount of energy stored within that glucose, your cells need oxygen. The process that uses oxygen to convert food into usable energy is called cellular respiration. This process takes place inside tiny powerhouses within your cells. These are called mitochondria. You can think of mitochondria as microscopic furnaces. Inside these furnaces, glucose is broken down in a series of complex chemical reactions. Oxygen acts as the final and most crucial ingredient in this process. It helps to efficiently burn the fuel, releasing a tremendous amount of energy. This energy is not released as heat, like in a real fire. Instead, it is captured and stored in a special molecule. This molecule is called adenosine triphosphate, or ATP. ATP is the universal energy currency of the cell. Every time a muscle contracts, a nerve fires, a cell repairs itself, it spends ATP. Your body is constantly making and using ATP to power everything it does. Cellular respiration, with the help of oxygen, is by far the most efficient way to produce ATP. For every 1 molecule of glucose, this process can generate about 38 molecules of ATP. Without oxygen, Cells can still make a little bit of energy through a different process, but it is far less efficient, producing only 2 molecules of ATP. This is why oxygen is so critical for complex, active organisms like us. It allows for a high-energy lifestyle. This direct link between oxygen and energy production is why your breathing rate changes with your activity level. When you exercise, your muscles need a massive amount of ATP to contract. To produce that ATP, your mitochondria need more oxygen. Your brain senses this increased demand and sends signals to make you breathe faster and deeper. Your heart also beats faster to pump the oxygen-rich blood to your muscles more quickly. When you are resting, your energy demands are low. Your cells need less ATP, and therefore less oxygen. As a result, your breathing and heart rate slow down. Your body is a master of supply and demand. The respiratory system is full of amazing details that often go unnoticed. Here are 5 incredible facts that highlight its complexity and efficiency. First, consider the sheer scale of your lungs. Your lungs contain between 300 and 500 million alveoli. Stretch those tiny sacs out and they'd cover an entire tennis court. That vast area is essential for absorbing enough oxygen to meet your body's demands. An astonishing amount of biological real estate packed into your chest. It maximizes the interface between air and blood. Second, think about the speed of the process. A single red blood cell's journey through lung capillaries is incredibly brief. It takes less than 1 second to pass the alveoli, dump carbon dioxide, and load up on oxygen. Your heart pumps about 5 liters of blood through your lungs every minute at rest. During intense exercise, that rate can increase 5-fold. This rapid transit keeps oxygen flowing to tissues constantly. Third, there's a brilliant built-in air filtration system. The air you breathe isn't perfectly clean. It's filled with dust, pollen, bacteria, and other microscopic particles. Your nose is the first line of defense. Tiny hairs called cilia trap particles. A sticky layer of mucus also catches intruders. Your trachea and bronchi are lined with cilia and mucus too. The cilia beat in coordinated waves, sweeping trapped debris upward. You then clear that material by swallowing or by coughing. This mucociliary escalator is a silent, continuous cleaning mechanism. Fourth, most of your body needs oxygen, but some cells have a short-term backup. Muscle cells can produce energy without oxygen for brief, intense efforts. This is anaerobic respiration. It's less efficient and produces lactic acid, which causes muscle fatigue. Still, it lets you do short bursts of power, like sprinting. Brain cells, however, are far more vulnerable. They need a constant oxygen supply. Brain cells can begin to die within 3 to 4 minutes of oxygen loss. Fifth, you have conscious control over your breathing. Unlike heartbeat or digestion, you can change your breathing pattern. You can hold your breath. You can breathe deeply and slowly. You can breathe rapidly and shallowly. That conscious control affects your physiology. Slow, deep breathing activates the body's rest and relaxation system. That can lower your heart rate. It can reduce blood pressure. It can calm your mind. Your breath is one of the most powerful tools to manage stress and influence health. Our lungs are resilient, but they are not invincible. The choices we make every day have a profound and direct impact on the health of our respiratory system. Perhaps the most significant factor is exposure to smoke. Smoking cigarettes, inhaling secondhand smoke is incredibly damaging to the lungs. The toxic chemicals in smoke irritate the airways, causing inflammation and excessive mucus production. More destructively, smoking gradually destroys the delicate walls of the alveoli. This damage is permanent. As the alveoli break down, the total surface area available for gas exchange shrinks, leading to a condition called emphysema and making it harder and harder to breathe. Conversely, clean air is a gift to your lungs. Spending time in nature away from urban pollution and industrial smog allows your respiratory system to function at its best. The air quality in your home and workplace also matters. Proper ventilation, air purifiers, avoiding harsh chemical sprays. Your lungs have a remarkable ability to clean themselves, but constantly bombarding them with pollutants overwhelms this natural defense system. Making a conscious effort to breathe cleaner air is one of the kindest things you can do for your long-term respiratory health. It supports the lungs' ability to do their job without added stress. Physical activity is another cornerstone of lung health. When you engage in regular aerobic exercise like brisk walking, running, swimming, or cycling, you are giving your respiratory system a workout. Exercise does not increase the size of your lungs, but it strengthens the muscles involved in breathing, including your diaphragm and the muscles between your ribs. It also improves your body's ability to use oxygen. Your heart becomes more efficient at pumping blood, and your cells become better at extracting oxygen from that blood. Over time, this means you can perform daily activities with less effort and less shortness of breath. Finally, good nutrition plays a vital supportive role. Your body needs specific nutrients to maintain a healthy respiratory system. Iron, for example, is a critical component of hemoglobin, the oxygen-carrying molecule in your red blood cells. A diet lacking in iron can lead to anemia. Foods rich in iron include lean meats, beans, lentils, and dark leafy greens like spinach. Additionally, antioxidants found in fruits and vegetables can help protect lung tissues from damage caused by inflammation and pollutants. A balanced diet provides the building blocks for healthy lungs and blood. While the lungs are the site of gas exchange, they do not have the ability to move on their own. The work of breathing is performed by a team of dedicated muscles, led by a silent and powerful captain, the diaphragm. The diaphragm is a large, parachute-shaped sheet of muscle at the base of your chest, separating chest and abdominal cavities. It is the primary muscle of respiration, responsible for about 80% of resting breathing effort. Its movement is rhythmic and steady, and almost always involuntary, managed by the brainstem. When you inhale, the brain sends a signal down the phrenic nerve. The diaphragm contracts and flattens, moving downward. That movement pushes abdominal organs down and out, which makes your belly expand on a deep breath. The downward motion increases vertical space in the chest cavity. At the same time, the intercostal muscles between your ribs contract. They pull the rib cage upward and outward. Together, these actions expand the chest in all directions, creating more volume for the lungs to fill with air. Exhaling at rest is simple and passive, no muscular effort. After contracting, the diaphragm and intercostals relax. The diaphragm rises back into a dome, the rib cage moves down and in. Chest cavity volume decreases. The lungs' elastic recoil causes them to gently shrink. That compression pushes air rich with carbon dioxide out. It's an energy-saving, elegant design. But sometimes you need more force. When you exercise, cough, or sing, you need faster or more powerful airflow. The body recruits accessory muscles to help. For forceful inhalation, neck muscles can lift the rib cage higher. Chest muscles can also help lift it. For forceful exhalation, abdominal muscles contract, pushing the diaphragm up faster. You can consciously control these muscles. Practicing deep diaphragmatic, belly breathing, can strengthen the diaphragm, improve lung efficiency, and trigger deep relaxation. The journey from a simple breath to the creation of ATP is a quiet, unseen miracle. It is a story of magnificent design and flawless cooperation. Vast, branching architecture of your lungs. Millions of red blood cells working tirelessly, every step perfectly synchronized to sustain your life. The great exchange of gases in your alveoli. The powerful, rhythmic pulse of your diaphragm. The final spark of energy in your cellular powerhouses. All working in harmony. This is not just a biological process. It is the rhythm of your existence, connecting you to the world with every breath. Understanding this process empowers us. It turns an unconscious act into wonder and a tool for well-being. Our daily choices affect this delicate system. Avoid smoke, seek out clean air, move your body, eat nourishing food. These choices directly support lung health and energy efficiency. These are not small things. They are powerful acts of self-care that protect respiratory health for a lifetime. For more amazing anatomy facts, hit like and subscribe to The Human Blueprint.